Good morning everyone. Myself Himanshi Singh. Today I am going to explain the topic that is theory of finite automata. So first of all, we are going to learn the categories of finite automata. Here, finite automata is divided into two parts, that is finite automata without output and finite automata with output. Therefore, next, the finite automata without output is further divided into three categories, that is DFA, NFA or NDFA or ENFA or ENDFA. As DFA is deterministic finite automata, NDFA is non-deterministic finite automata, and ENFA or ENDFA is non-deterministic finite automata with E moves. And here finite automata with output is divided into two parts, that is Moole machine or Mealy machine. Now we are going to learn about the basic introduction about the finite automation theory. Finite automata is an abstract computing device. It is a mathematical model of system with discrete inputs, outputs, states and set of transition from state to state that occurs on input symbol from alphabet sigma. It having the three representation, that is graphical, tabular and mathematical. So here from the definition we have read that finite automata is abstract computing device, that is it having a input, it takes input as a symbols or as a five tuples that we are going to learn later. So first of all we are going to learn what is the representation and what are the ways to represent finite automata, that is graphical, tabular, mathematical. Now we are having the formal definition of finite automata, that is a finite automata is having a five tuples. They are q, sigma, psi, q naught and f. So these are the five tuples. As we have five tuples, so we are going to learn what are the need of these five tuples and what are the conditions they have. Where Q is a finite set called the states, it is a set of states. Sigma is a finite set called the alpha. Psi is transition function, which is given by it is a function, therefore it is given by the product of Q and sigma, which gives the next state is the transition function. Now q naught is belongs to q, that is set of state. It is a start state also called initial state. Now f belongs to or subset of q is the set of accept state also called final state. Here q naught is initial state and f is final state. Now we are going to learn about transition diagrams. Transition diagram also known as transition graph. It is directed graph associated with the vertices of the graph correspond to the state of finite automata. Let us understand with this diagram or graph. Here q naught is the initial state, or you can say that start state. On giving the input 0, it gives the same output as the input, that is having the self loop. Now if we are giving 1 as an input, and it will give the next stage from next state, that is q1. Now q1 having the same input, that is 1, and it will give the same output state as the initial state q1. Now on giving 0 as an input, it will give the next state, that is q2, and it is final state, therefore it is called as accepting state also. And it also has self loop on giving 1 as an input. Now we are having here in the diagram three states, that is q naught, q1 and q2. Q naught is start state, q1 is intermediate state and q2 is final state. Now the final state is represented by two rings or two circles, and now from the diagram we have seen that 0 and 1 are only the inputs. Now we are going to learn about the transition table. It is basically a tabular representation of the transition function that takes two arguments, a state and a symbol, and returns a value that is next state, represented by the transition function that we have earlier learned. Now transition function, the mapping function or transition function denoted by psi. Two parameters are passed to this transition function, that is first current state and the second is input symbol. The transition function returns a state which can calculated as next state. Psi, that is current state, and then current input symbol, comma, and then it will give the next state. Now we are going to learn with example. Here you can see that the psi is a function, and according to the above formula or function, we can write that q naught is a at the place of current state, therefore it is known as current state, and 0 at in current input symbol, and therefore it is input signal. Now it gives the next state, that is q1.